Here's what you do now. It's a little simplified for some of these problems. Please find the derivative and then find the slope at a given point. So for the first one, we got negative 4x minus 2 when you take the derivative. And then when you plug in negative 2, because we plug in the x point, you end up with 6. Alrighty, try the next one. For the second one, we end up getting 9x squared, and then when you multiply this, negative 8 over 3 x to 1/3, or the cube root. And for the last one, when you take the power, put up front, and then subtract 1, you should get 1/3 x to the negative 2/3, I believe, if I did that right in my head. That's simplified further. Alrighty, there's a little bit to unpack here. So the 9x squared, that's straightforward, don't need to talk about it. And then over here, this ends up being a cube root, because when you have a negative 1/3 power, that's a radical, and the denominator of that power would be how big that radical is. So cube root. Now for the last one, when we talk about this bad boy right here, now we have a 1/3 up front. So the 3 is in the denominator. When you are left with a negative 2/3 for the exponent, then that's the same thing as saying the cube root of x squared. But because it's negative, the cube root of x squared goes down here. Wow! Did that black writing just turn red? Alrighty. Let's plug in numbers now. So now we plug in 1, and we end up with 9 minus 8 over 3 minus 1/3. And then when you get the common denominator, it's 27 minus 8 minus 1 over 3. Of course, I may have made a mistake. So make sure when you do it that you do not make a mistake. Alrighty, so we should end up with 18 over 3, which equals 6. Alright, let's move on to the next problem.
I wish I had a stroller. I would have taken the kids.
Yeah, the side-by-side one?
No. Just the little one. Just put it in the stroller.
Mm-hmm.
And actually I can hold her hand to warm it.
True. Alright, on this one is already done. So you have a radical, you change it to a power, and then you multiply by 1/2, subtract by 1, which is why you have this bad boy right here. And when you plug in 1, you should end up with 1 over 2 times square root of 4, which is 1 over 4. Alrighty, let's move on. So, if you want to take a derivative of something like this, it's important that you first turn it into terms where the power is obvious. So, let's talk about this. I first rewrote it for no reason whatsoever. I love how when you highlighted the writing turns green too. And then let's use yellow. Then I took the derivative, which is why you see the prime. And this one and this one, it's going to be hard to talk about later. And when we write here, I pretty much, this is easy.
Get your family.
I first multiplied the, I just first wrote the numerator, so the 4 is on top.
No, not that one.
The negative will bring it down, and it's to the 1/5, which is why it's the 5th root. Now for the second one, you have 2 on the numerator, and you have a 5 on the denominator. Now when you have a to the negative 3 over 5th, that means that we're going to go down, which is why it's in the numerator. This brings down a 5th root. This brings a to the power of 3, which is why we have the 5th root of x cubed. Let's continue. So we got the graph f of x, and we want to sketch f prime, which is the slope of f of x. So let's get started. We know that the slopes at these points are going to be 0, which is why I marked where on the x-axis where it's going to be. At -2 we should have a 0, and at 0 we're going to have a 0. Now the only thing left to do is to find out when the slope is positive and it's negative. You can see that the slope here is very steep and it's also very negative. But then as we get to where it's 0, it's going to become, it's going to get closer to 0 and then change into a positive slope. And then from here, it's changing again and turning into a negative slope. So let's draw this. I know what you want to say. My graph looks epic. I'm using a different pen this time around. It's not a very fine tip, but still does the job. That would be the slope that would be the derivative, which pretty much represents the slope at any given point. What I mean by that, at x equaling -4, if my graph was to be correct, you could say that the slope is -6. So that's kind of what that graph means. Let's move on. Alrighty, so the graph of f is shown in the figure above. Which of the following could be the graph of the derivative of f? Alright, well, clearly you know what the answer is. The answer is already shown, which seems to be A. Well, let's see if that's actually true. Maybe it's not A. So let's find out. We know that the derivative is going to be 0 at these points because we have a plateau or minimum. At least we could say that we have at least happening a plateau. So at these points, we're going to have 0. So far the graph seems to be correct. Now when you look at the tangent lines, you can see that over here, these are all positive slopes. So that positive, it starts off from 0, then it's getting bigger and bigger and bigger. At that point, you're noticing that the slopes start to go low again, and then it's back to 0 right here. By the way, I did forget to mark the 0 one. My bad. So let me just go ahead and do that. You're supposed to mark when the derivative is 0 to help you graph it. After that, we start having negative slopes, which is why we're underneath the x-axis. And again, we're going to be at 0. So this is indeed the correct one. Alrighty, let's move on. For this problem, the graph of f prime is shown. Find the intervals where f is increasing, decreasing, and find the maximum minimums. F is increasing when we have a positive slope. Well, a positive slope by definition is the y rises as x increases. So when do we have a positive slope? We have a positive slope right here. And also right here. So when it comes to increasing, I would say -1, not including a -1, all the way up to 2. And then we attach the other part of that domain, which is, so I shouldn't have used domain, set. Alrighty. Now decreasing would be happening at these. So let me go ahead and write it down. So decreasing is happening from -infinity, not including -infinity, all the way to -1, not including -1, and 2 to 4. Alrighty. Now, as far as when the maximum minimum is happening, you just have to ask yourself, well, when is the derivative positive and negative? What does that mean? So let's figure it out. I'm going to use red from here on out. We have negative slopes, and then we have positive slopes. Well, that means that at that point, we first had something decreasing, something was going lower and lower and lower, and then suddenly it was increasing, which means that this is a minimum. So the minimum is happening at -1, and by that I mean x equals. And let's see, then right here, we were in a positive region, and then we have negative slope. So something was increasing and then decreasing, that's a maximum. So maximum is happening at x equals 2. And then we were in the negative and then suddenly positive, which means something was decreasing and then increasing again, that's again a minimum. So that's happening at, and I can't even read it, I did so much erasing. What is that? That's a 4. Righty, let's move on. Alright, here's another one. So go ahead and pause the video and try it out. So we have increasing infinity to -2, 1, 2, 3. Then we have decreasing of -2 to 1, and then 3 to infinity. Now when is it a maximum, when is it a minimum? So let's try those. As mentioned before, since we start off having a positive slope and then a negative slope, something was increasing and then decreasing, that implies a maximum. So -2 is a maximum. I'm going to write those down in a second. And then we are at a negative slope changing to a positive slope, meaning that something was decreasing and then increasing, that's a maximum. And lastly, we had a positive slope which switches to a negative slope, which means something was going up and then down, that's a maximum. So let's go ahead and write those down real quick so we have it in our notes. There you have it. The maximum is happening at -2 and 3 because in both of those cases we first had a positive slope and then a negative slope, which means something was going up and then going down. And at 1 it's a minimum because we first had a negative slope, something going down, which changes to a positive slope going up. That's a minimum. Alrighty, let's continue. For each, find the interval of increasing and decrease, of increase and decrease, the maximum and the minimums. So first we want to find the derivatives. So please do the derivatives now. Here they are. We got -2x plus 6 for the first one, -3x squared plus 6x, and -3x squared minus 6x minus 9. What you want to do now is make them all equal to 0 and find when they equal 0. So for number 3, when I analyze it, I know it's 0 at 3. So I want to know what happens when we have a number very less than 3, let's say 0. When you plug in 0, you're going to end up with a positive value. And a number to the right of 3. So let's say 10. So -2 times 10 is -20, plus 6 is still negative. So if you have a derivative that first is positive on the left-hand side, so it's increasing, but then it's negative on the right-hand side, which is decreasing, which implies that's a maximum. So the maximum, in this case, for the first one, happens at x equals 3. So let's do another one. When looking at the problem, you find out that it equals 0 at 0 and 2. When I say it's a problem, I mean the derivative of number 4. So let's find out what happens in these regions. When you plug in, let's say, -100. So -100 would make this a negative value. It would make this a negative value, overall a negative value. When you plug in 1, it would end up giving you -3 here and 6 here. That's positive. And when you plug in 100, positive 100, that will make that a very large negative value because you are squaring a 100 and then multiplying by -3, and that's going to be 600. So overall, this is going to be negative. So we first have a decreasing y and then an increasing y, so that will be a minimum at 0. And then we have an increasing and then a decreasing, so that would be a maximum. So max at 2, so max at x equals 2, and min at x equals 0. And then the last one. I was in the middle of doing it and I just realized that I took the derivative of this spot right here incorrectly because that's not factorable. So I thought there must be something wrong, and it was, because the derivative of 6x squared is not 6x, it is 12x. So please forgive my writing, 12x for that one. So let me make the adjustments, we continue. So when you factor it out, you end up getting x plus 3 and x plus 1. So when you look at these, that's going to be -3 and -1. So we want to look at these regions. When you plug in negative infinity, then we're going to end up getting a negative here, 3 negatives will give you a negative. When you plug in, let's say -2, that would make this a positive. This would be a negative, so that will give you a positive, because negative times negative is positive. And when you use a number like 0, then you would end up getting a positive. So that would be positive, that would be positive, and we have a -3. So that would be a negative again. So, what do we end up with? We have a decreasing, then increasing, and then we have an increasing, then decreasing. It's a minimum at -3 and a maximum at -1. So go ahead and list those in your answers, and this video is finished. Awesome. See you guys soon.